All right, storage versus memory for data location. Solidity, there are two locations you can store variables: in storage and in memory. Storage refers to variables stored permanently on the blockchain. Memory variables are temporary and are erased between external function calls to your contract. Think of it like your computer's hard disk versus RAM. Most of the time, you don't need to use these keywords because Solidity handles them by default. State variables, variables declared outside of the function, are by default storage and written permanently to the blockchain, while variables declared in functions are memory and will disappear when the function call ends. And you might be thinking to yourself, why does this matter? Well, storing things on the blockchain costs money. So if you don't want to spend a lot of gas on deployment, you probably want to not store so many variables, especially if you don't have to. However, there are times when you do need to use these keywords, namely when dealing with structs and arrays within functions. So let's look at this code. We have a contract sandwich factory. We have a struct sandwich with a name and a status. Okay, we have an array of sandwiches. We have a function called eat sandwich. So let's say you wanted to make a new struct, right, in your function. Seems pretty straightforward, but Solidity will give you a warning telling you that you should explicitly declare storage or memory here. So instead you should declare with the storage keyword like sandwich storage my sandwich. In which case my sandwich is a pointer to the sandwich of index in storage, and my sandwich dot status equal eaten. This will permanently change sandwich's index on the blockchain. And that's because it's right here. So this is a variable in the smart contract. It's not just in the function. If you just want to copy, you can use memory, sandwich memory, another sandwich, and it'll just be a copy in the memory, and it's a temporary variable, and it will die after the end of this function. So difference is this one is actually storing it over here, where this is an actual variable in the smart contract. This one is the temporary variable, and it's only for pretty much the lifetime of this function. Don't worry if you don't fully understand when to use which one yet. Throughout this tutorial, we'll tell you when to use storage and when to use memory. And the Solidity compiler will also give you warnings to let you know when you should be using one or the other of these words. For now, it's enough to understand that there are cases where you'll need to explicitly declare storage or memory. So now let's put it to the test. It's time to give our zombies the ability to feed and multiply. When a zombie feeds on some other life form, its DNA will combine with the other life form's DNA to create a new zombie. Create a function called feed and multiply. Okay. I'm trying to beat the time right here. We have a minute 22. All right, cool. Let's see. It'll take two parameters, zombie ID, which is a uint, target DNA, which is a uint, and then it's going to be public. We don't want the last. We don't want to let someone else feed our zombie. So first, let's make sure we own this zombie. Add a require statement to verify the messenger sender is equal to the zombie owner, similar to how we did in create random zombie. So require message.sender equals. Let's go back here. It doesn't look like we have it already. Oh, right here. Make sure you own this zombie. So we'll add a require statement to verify message.sender is equal to the zombie's owner. So we do have a mapping here. Zombie to owner. Okay, and that's a uint is the zombie ID. And the value is a address. So that is going to return the address owner of this guy. So that should be good. We're going to need to get this zombie's DNA. So the next thing our function should do is declare a local zombie named myZombie, which will be a storage pointer. All right. Zombie, my zombie. We want it to be a storage. Equal to index zombie ID in our zombies array. Where's the zombies array? Right there. Okay, cool. Set this variable to be equal to index in our zombies array. So that should work. You should have 4 lines of code, including the line. Yep. Let's check the answer. Looks good.